Good morning, students. Welcome back to the chemistry class. Okay, students, in the last class we have seen some of the points in this chapter, the structure of atom, in the very first revision class. And in today's class also we are going to see some of the important points. Okay, so this is the second revision class of chapter 4, that is the structure of atom. So in the last class we have seen some of the important points regarding the atom, and then we have seen the ancient view of atomic structure, the view of Carnot and the views of Democritus and Leucippus, and then we have seen about the Dalton's theory. Okay, so how atom concept came into existence, and then we have seen about the discovery of electron. Okay, so how discovery of electron took place. So it took place in discharge tube, and then we have seen about the discharge tube, what is the construction of the discharge tube and how the necessary conditions were achieved in the discharge tube. Okay, and then lastly we have seen how cathode rays production took place in the discharge tube. Okay, so all these things we have seen in the last class. So in today's class we are going to see some of the characteristics of the cathode ray. Okay, so let's see that. Sir J.J. Thomson performed experiments to study the properties of cathode rays and found out that cathode rays have the following characteristic. So Sir J.J. Thomson performed various experiments in order to come to the conclusion which we are going to study. Very first characteristic was they originate at cathode and travel in straight line. Okay, so in order to prove it, he made this setup which you have just seen. Okay, where an object was placed in the path of the ray. Okay, so what happened when an object is placed in the path of cathode rays? A shadow of the object falls on the wall opposite the cathode. Okay, a shadow can be formed only when the rays travel in straight line. Okay, so this was the conclusion. Okay, so when an object was placed in the path of cathode rays, a shadow was formed, and this shadow can be formed only when the rays travel in straight line. So this proved that cathode ray travel in straight line. Okay, so I think that this concept is clear. Okay, now let's see the next. Cathode rays are a stream of particles. Okay, so how this was proved? A light paddle wheel placed in the path of the cathode rays rotates. This shows that some particles strike the plate of the wheel. Okay, so when rays were passing, the wheel start to rotate. Why it was rotating? Because some particles would have struck it. Okay, so this proved that the cathode rays are made of some particles. Okay, so by this experiment he came to this conclusion: cathode rays are stream of particles. Third characteristics, the particles constituting cathode rays are negatively charged. So how this was proved? It was found that on applying electric field, as you can see here, electric field is applied. Okay, cathode rays were attracted by the positive plate and repelled by the negative plate. Okay, so this ray was attracted toward the positive plate, and as you already know, opposite attract. So negative will be attracted by the positive. So if positive plate is attracting, this means that the cathode rays are made of negatively charged particle. Okay, so I think this is clear. Okay, next, fourth, the particles constituting cathode rays are all alike. They do not change with the gas, the electrodes and the kind of glass used for making the tube. So they do not change by any of these conditions. Okay, they are all alike. Particles constituting cathode rays are all alike. So J.J. concluded that particles constituting cathode rays are a universal constituent of all atoms. So it is same for all atoms. Okay, so these particles were named what? Electrons. So this is how electron discovery took place. So I think all these points are clear. So we have already studied in detail when I was teaching this chapter. Okay, so now you have to learn all the characteristics which we have seen just now. Okay, and you have to understand how this characteristic came into existence. And for that, you have to understand the experiment which Sir J.J. Thomson has performed. Okay, so I hope that these experiments are clear. Next, properties of electrons. So very first property is what? An electron is a negatively charged particle. Second property, it carries a negative charge of -1. Third, the mass of an electron is 9.11 into 10 to the power -3 kg, which is only 1 by 1848th of the mass of an atom of hydrogen. Okay, so it's very less. Okay, therefore an electron mass is treated as negligible. Okay, so this is very less, which can be neglected. Okay, almost nothing. Okay, so I hope that electron concept is clear. Now let's see how the discovery of protons took place. Okay, an atom is electrically neutral, which we already know, but the electrons present in it are negatively charged particle. Hence the atom must also contain some positively charged particle, so that the overall charge on it becomes 0. So this was the thought, that atom is electrically neutral, so this means that positive charge should be there along with the negative charge. The search for those positively charged particles led to some experiments by German scientist Eugen Goldstein. Okay, so Goldstein performed some of the experiments in order to find positively charged particles which will neutralize the negative charged particles of an atom, and then only the atom will become what? Electrically neutral. So let's see. So how anode rays production took place. So this also the production took place in discharge tube only. Okay, so Goldstein repeated the cathode ray experiment using a perforated cathode. Now instead of opaque cathode, he used what? Perforated cathode, the cathode which is having holes. Okay, he observed that there was a red glow on the wall opposite the anode. Okay, opposite the anode there was one red glow. Okay, so some rays must have traveled in the direction opposite to that of the cathode rays, that is from anode towards the cathode. How this red glow is produced? So some rays must have traveled from anode to cathode. Okay, that is from anode towards the cathode. These rays were called anode rays or canal rays. Now why they were named as canal rays? Because they were moving through the perforation, or you can say canals, why they are also known as canal rays. So all these things I have already explained. It was found that these rays contain positively charged particles, and so J.J. Thomson called them positive rays. So anode rays is also known as canal rays and positive rays. Clear? So I think that this experiment is clear. So instead of opaque cathode, perforated cathode was used, so that rays able to travel through it. Then only this red glow was observed. Okay, so I think all these things are clear. Next, now let's see some of the characteristics of the anode rays. So like cathode rays, anode rays are also having some of the characteristics. The characteristics of the anode rays were found by carrying out experiments similar to those with cathode rays. Now same experiment which we have seen in the case of cathode rays, in anode rays also, in finding out the characteristics of the anode rays was performed. So in order to prove that anode rays travel in straight line, the same setup was done. Okay, and in that same setup it was observed that shadow was casted. So if shadow of the object was casted, this proved that anode rays travel in straight line. Then second property, anode rays are a stream of particles. So now what happened? As they can rotate the light paddle wheel placed in the path, so this proved that anode rays are also what? Stream of particles. And because of that only, the paddle was moving. Light paddle wheel was, you can say that the wheel was moving. It is due to the particles. Now, the following features distinguish anode rays from the cathode rays. So, these are some of the similar characteristics. Now, let's see some of the dissimilar characteristics. Anode rays are stream of positively charged particle. Cathode rays are what? Stream of negatively charged particle. But anode rays are a stream of positively charged particles. Why? As they bend towards the negative plate in an electric field. Now, instead of bending towards the positive plate, the anode rays bend towards the negative plates. So, positive will attract negative. So, that is why it was concluded that anode rays are stream of positively charged particles. Now, next, the particles constituting anode rays differ with the gas used in the discharge tube. So, now here particles constitute the anode rays were differing with the gas used. So, these particles now, positive charged particles, are not universal. They will change from atom to atom. Okay. So, I think that this concept is clear. Okay. The characteristics of the cathode rays, the characteristic of the anode rays, and how the production of anode rays took place. Okay. So, all these things are clear. Okay. So, with this I would like to conclude today's revision class. Whatever points which we have discussed today, you just read them and underline important points, learn important definitions. Okay. So, that's all for today, students. Thank you.